Have you ever wondered why lifting a box feels harder the faster you do it? Or why a 100-watt light bulb is brighter than a 40-watt one, even though both just sit there and glow? These questions all come down to three core ideas in physics: energy, work, and power. They're connected, but they're not the same. And if you're taking physics, you need to know exactly how they differ. So let's break it down. Start with energy. Energy is the capacity to cause change. It's something a system has. If you're holding a ball above the ground, it has gravitational potential energy. If it's moving, it has kinetic energy. The formula for kinetic energy is 1/2 mv squared. That's 1/2 times mass times velocity squared. The faster or heavier the object, the more kinetic energy it has. For gravitational potential energy, the formula is mgh. That's mass times gravity times weight. The higher the object, the more energy it stores. Energy is measured in joules. 1 joule is 1 Newton meter. And energy is conserved. It can't be created or destroyed, only transferred or transformed. That's the first key idea. Now, work. Work is how energy moves. It's not something an object has, it's something that happens. Specifically, work is done when a force causes displacement. The formula is W equals F times D cosine theta. That's force times displacement times the cosine of the angle between them. If you push a box with 50 newtons of force for 3 meters in the same direction, you do 150 joules of work. If the force is perpendicular to the motion, like holding a bag while walking horizontally, the work is 0. No displacement in the direction of the force means no work. Work is also measured in joules because it's a transfer of energy. Positive work adds energy to a system. Negative work takes energy away. Friction, for example, does negative work. It opposes motion and removes energy from the system. Now, power. Power is how fast energy moves. It's the rate of doing work. The formula is P equals W over T. That's work divided by time. If you do 100 joules of work in 10 seconds, your power output is 10 watts. If you do the same work in 5 seconds, your power is 20 watts. So same energy, different rate, different power. Power is measured in watts. 1 watt equals 1 joule per second. There's also an instantaneous version, P equals F dot V. That's force dotted with velocity. It tells you the power at a specific moment. Let's put all three together with one example. Say you lift a 10-kilogram box 2 meters upward at constant speed. Gravity is 9.8 meters per second squared, so the energy gained is mgh, which is 10 times 9.8 times 2. That's 196 joules. That's the gravitational potential energy stored in the box. The work you do is also 196 joules because you applied a force equal to the box's weight over a 2-meter displacement. Gravity does negative work, minus 196 joules. The net work is 0 because the box moves at constant speed, no change in kinetic energy. Now, if you lift the box in 2 seconds, your power output is 196 divided by 2, which is 98 watts. If you lift it in 1 second, your power is 196 watts. Same energy, different time, different power. Let's compare them side by side. Energy is a stored quantity. Work is a transfer process. Power is a rate. Energy and work are both measured in joules. Power is measured in watts. Energy depends on the state of the system, its speed, height, or configuration. Work depends on force and displacement. Power depends on work and time. Now, some common misconceptions. First, work and energy are the same. No. They have the same units, but different meanings. Energy is what a system has. Work is how energy moves. Second, if I'm holding something, I'm doing work. Not in the physics sense. If there's no displacement, there's no work. Your muscles might be burning energy, but mechanically, no work is done. Third, powerful means lots of energy. Not necessarily.
Power is about how fast energy is used. A camera flash and a light bulb might use the same energy, but the flash does it in a fraction of a second. That's high power. Here's a mental model to remember. Energy is like money in a bank account. Work is a money transfer. Power is how fast the money moves. Energy tells you how much capacity a system has to cause change. Work tells you how that energy moves through forces and distances. Power tells you how quickly that transfer happens. So next time you see a problem, ask yourself, are we talking about how much energy something has? That's energy. Are we talking about a force causing displacement? That's work. Are we talking about how fast something is happening? That's power. Keep those distinctions clear and you'll be ready for anything physics throws at you.